All right, so if we are to differentiate this one here in number 6F, in the cumulative review, 6F, cumulative review, chapters 8 to 10. So okay, so in calculus, there's a lot of differentiation rules. We've covered most of them. There's integration techniques, how to integrate, take the antiderivative and integrate functions. We've taken a look at very few of those, just the use substitution and kind of a direct antiderivative approach. So there are things that we don't have a shortcut for. If you recall, we've done x to the power of a constant, right? Like 2. We know how to take the derivative of that. So y prime here, this, number comes down, right? And that's 2x to the minus 1, 2x to the 1. So that's one thing. We haven't done this though, right? We haven't taken a look at this specific case where we have like an x to the power of another function. We've had sorry, just let me think here. The exponential functions here, where we have an x in the power here, it's not the same as just bringing an x down and then what is x minus 1 to the power of x minus 1. So this is a little bit different. If we have just a number up here, that's fine. Now, e to the power of x, we've done, right? So e to the power of x, we've done. So we haven't done x to the power of x, but we've done e to the power of x. So when we have x to the power of another function, there's not really a direct differentiation method for that. We have to figure out how we can rewrite this, manipulate this, because e to the x we can take the derivative of, but x to the x we can't take the derivative of. Okay, so what that means is that we have to fundamentally change this equation, how it looks, we have to get tan x out of the exponent position. So we have to introduce logarithms. So we're going to have to take the natural logarithm, and of course in calculus we take the natural logarithm. It's way easier to take the derivative of. We'll take the natural logarithm of both sides. Okay, so then we have, ln y is, now remember the power rule. I'll just do this all in one step. The tan x now can be brought out of the exponent position because that exponent can just come down as a multiplier. It doesn't matter what this is. So this is tan times ln x then. Okay, so this looks crazy, maybe a little bit crazier, but we don't have x to the power of x or x to the power of a function. So that's good. We just have product rule, which we know how to do product rule. I know how to take the derivative of tan and ln of x, and I can take the derivative of ln of y. It's just going to have to be implicit differentiation. Okay. So when it says differentiate, this is d dx, okay? So we are doing d dx of this original function, right? So that means with respect to x. So now that we've got it in this format, again, we've avoided this x in the exponent position. So ln of y is going to be 1 over y, the derivative, times y prime, because we're implicitly differentiating. Now we have to think about product rule. Okay, product rule. So the derivative of tan is secant squared, right? Oops, secant squared x. Okay, so it's the derivative of the first times the second, plus the first times the derivative of the second, which is 1 over x. Okay. So can we do some simplification? Really what we're after is this, right? So we're after dy dx, right? So dy dx is what we're after. This is now Newton notation here. So finding y prime is with respect to x, right? That's respect to x. So I'm going to multiply everything by y. So y prime is, I don't know if we can simplify this much, but y times, I don't know, secant squared x 1x plus tan x over x. And the only other thing that we would probably want to do, again, if we're taking the derivative with respect to x, we would want to write it in terms of x, right? And so this y that we have here, remember our original question, y equals x tan x. So the final step would be x to the power of tan x times this. And if tan x over x, you can leave it like that. That's fine. Yeah. So that's the answer to that one. So that would probably be the toughest differentiation that you'd have to do. Okay. And what was the key here? Okay. So the key was noticing that we have a function in an exponent position for an actual variable here, x. So x to the power of x, we can't do that one. We can't really do that one. We have to get it into a product rule situation, right? So like I say, x to the power of x, we would have to take the ln of that, so that's x times ln x. Then we have a product rule situation. This is good. This is not good, if that makes sense. So that might be something you just want to note for going forward.
Could I take a picture?
Could you take a picture of this? You weren't writing this down?
No, because I was on my review, so I didn't want to write it on my review, because it's not.
Yeah, go ahead. Okay. Anyone else? We need a photo op. Camera's going up. How's this? This one look good? Can you get your hand out of the way, Mr. Maxwell? Can you get your hand out of the way? Oh, sorry.